Hi everyone, in this video we continue with questions 2, 3, 4 and 5 in paper 1 of the 2009 grade 12 NSC exams. By the end of this video you will have gained insight into what each question means, what is being tested and how to go about answering these questions. Give this video a thumbs up if it helped you, comment if you have any questions, subscribe to my channel if you want to get 100% for maths. Getting 99% for maths means you still need to learn 1%, and we aim high on this channel. The link for this exam will be in the description below. This meme shows how we can use simultaneous equations to prove that we shouldn't waste time studying. You're welcome. Okay, let's get into it. Question 2.1 reads as follows. Tebogo and Matthew's teacher has asked that they use their own rule to construct a sequence of numbers, starting with 5. The sequences that they have constructed are given below. We then see each sequence. Question 2.1.1 asks us to write down the nth term, or the rule in terms of n, of Matthew's sequence. What this means is that we will be using the letter n as a variable in the equations that follow. First, we rewrite the first 3 terms of the sequence. We only need 3 terms to be able to determine the type of sequence and the term rule. If the sequence has a constant difference, we use the small letter d for this, it is a linear sequence. If the sequence has a constant factor, we use the small letter r for this, it is an exponential sequence. Let's see what the first and second differences and factors are. We see that this sequence has a constant difference, making it a linear sequence. We then write out the general rule for linear sequences in terms of n, which we know by heart. We then substitute the values of a and d into this rule, where a is the first term and d is the constant difference. But we don't stop here, we want full marks. Thus, we do some algebra and we get the correct full marks answer. Question 2.1.2 asks us to do the same with the second sequence that is given to us. Again, we only need 3 terms to find the type and general rule for the sequence. First, we find out what type of sequence this is by calculating the first and second differences and factors. We see that the sequence has a constant factor, making it an exponential sequence. We then write out the general rule for exponential equations, which we know by heart, and substitute the values of a and r, where a is the first term and r is the factor. As we can see, this is the answer because we can't simplify further. Nice! Question 2.2 reads as follows. NOMSA generates a sequence which is both arithmetic and geometric. This means linear and exponential. The first term is 1. She claims that there is only one such sequence. Is that correct? Show all your workings to justify your answer. So this question is asking us to check if NOMSA is correct. We start off by writing a hypothetical sequence with the first term of 1, second term of x, and third term of y. We are going to use x and y to calculate possible sequences. So what this question is actually asking is, set the linear rule equal to the exponential rule and check if there are more than one possible sequences that can exist. We have a value for a. Now we need to calculate the values of d and r. The sequence 1xy we are working with has a constant difference and a constant factor because it is both linear and exponential. We are going to use this fact to generate 2 equations that we can solve simultaneously. We call them equation 1 and equation 2. We need to get one of the variables, either x or y, separate, so that we can substitute one equation into the other. In this case, it is way easier to get y alone in equation 1. Remember, this is an equation, so what we do on the one side, we must do on the other side. No takeovers. We are going to simplify equation 2 by multiplying by x over 1 on both sides, so that it will be easier for us to substitute. Now we substitute equation 1 into equation 2 and we see a parabolic function. We simplify by subtracting 2x and adding 1 on both sides. I'm going to factorize by shorthand. You can also use the formula on the formula sheet. We see that x must be equal to 1 for the equation to be satisfied. Please leave a comment and watch the previous video if you don't know what just happened. We substitute this value of x into equation 1 to find the value of y, which we see is also 1. Our sequence 1, x, y is thus 1, 1, 1. We want full marks, so we remember to write down the words Naamsa is correct at the end of the answer. Question 3 is testing to see if we can count correctly. And since we are smart cookies and we can count, we can rake up free 5 points. Question 3.1 asks us to write out the first 3 terms of the sequence. The trick here is that the sequence starts at 0 and not at 1, which means that term 1 is where t is 0. Terms 2 and 3 is then where t is 1 and 2. We can substitute these values for t and write out the sequence for our first free point. Question 3.2 asks us to calculate the sum of this starting at 0 sequence. We can do this in several ways, but I'm going to use the sum of linear sequences formula on the formula sheet. We need to get the question into the same format as the formula. We can do this by adding 1 to the top and to the bottom of the sigma letter. Now we can substitute the values of n, a and d into the formula. We have a, which is the first term. We can calculate d from the first and second differences, and we have n, which is 100. We then substitute these values into the formula, punch it into our calculators, and write down the answer that secures 4 more free marks. Good. In question 4, we are given a quadratic sequence. Question 4.1 tells us what we already know. The first derivative of a function is also a function. It then asks us for an expression for this first derivative. For this question, we are going to label the given sequence terms with the capital letter T, the first difference terms with capital letter D, and the second difference terms with small letter d. We then write out the first 4 terms for the first difference. The question is thus asking for a general term for d in terms of n. However, we need to figure out what kind of sequence d is. Just as in question 2, we check whether there is a constant factor or a constant difference. We find that there is a constant difference, thus we are dealing with a linear sequence for d. We then write out the general formula for linear equations and substitute the values of a and d, where a is the first term and d the constant difference. We want full marks, so we simplify the answer. Voila! Question 4.2 is testing whether we can count correctly. Again, the trick to this question is understanding the 35th difference lies between terms 35 and 36. We use the equation from question 4.1 to calculate the 35th difference. Easy. Question 4.3 is a standard question for every grade 12 paper, an expression for a quadratic sequence. It's important for us to remember the form of a quadratic sequence and the expressions for the first term, first difference, and second difference. We have the values for t1, d1, and small d1. We're going to use these 3 expressions as simultaneous equations to calculate the values of a, b, and c. And we're going to start with the easiest equation first, equation 3. We then calculate the value of a to be -1, which we can substitute into equation 2. We then calculate the value of b to be 4. We can then substitute the values of a and b into equation 1 to calculate the value of c. We then substitute the values of a, b, and c into the original expression of a quadratic sequence. Question 4.4 doesn't require us to calculate anything, but to explain something. We can see that the maximum term in the sequence has a negative value and that all the other numbers in the sequence are also negative. We write this out as plainly as possible. Just remember to write down the words "no positive number exists" for full marks. Question 5 tries to intimidate us with a story about a tree and by giving us some table, whatever. The important thing here is to see that there are two sequences. The first sequence is the tree height and the second sequence is the growth of the tree, where the second sequence is offset by 1 year. We can also interpret the information given about the growth of the tree as the tree growth is exponential with a constant factor of 8/9. Question 5.1 asks us to calculate the growth in the 17th year. It's important to read that correctly, and it's important to realize that the 17th year is the 16th growth year. We need a general term for the growth of the tree, so let's denote the growth sequence with capital letter G. We then write out the general term for exponential growth and substitute A, the first term, and R, the growth factor, into this expression. We can then substitute N for 16, as it's the 16th growth year, and punch it into our calculators to get the correct answer, which we write down with its unit. You can only get full marks for these kinds of questions if you write out the correct units. Question 5.2 asks us to calculate the height of the tree in year 10. This is equal to the height of the tree in year 1 plus the sum of 9 years of growth. To solve this, we are going to use the formula for the sum of exponential sequences where r is less than 1. Substitute the values for a, r, and n into the formula to get the sum of the growth years. Remember, this is not the final answer. We need to add this to the height in the first year. And also remember to add units to your answers. Great. Question 5.3 asks about the maximum height of the tree. To calculate this, we need to calculate the sum of the growth of the tree as if it was given infinity to grow. There's a formula for this on the formula sheet, which makes it super easy. Substitute the values for a and r into this formula to get the maximum growth of the tree. Again, this is not the final answer. We need to add this to the height of the tree in the first year, and we need to remember to write units next to our answers. For full marks, we also write the words, "The tree won't grow taller than 312 centimeters." Good job! Hello, little spooter. A friendly little spooter dropped down to visit while I was recording. I helped the fellow get to safety. No spooters were harmed during the making of this video. Thank you so much for watching. Please remember to leave a thumbs up if this video helped you. Please leave a comment if you have any questions or if you struggle doing this yourself. I'd actually really love to help you. Subscribe if you want to get 100% for maths. I changed the settings on my microphone, so hopefully this sounds a bit better. Let me know. I know you learned something in this video, and we tackle question 6 in the next video, so go ahead and watch that when it's up. Cheers!